continuing from the previous video. So see here, this is the first phase, this is the second phase in the upper hemisphere. If you consider this is a sphere, this is the sphere, right? This is the equatorial plane. So in the upper hemisphere we are finding two planes. In the lower hemisphere you are finding two phases. Okay, that means if we are taking fourfold rotation, you should find four phases in one hemisphere, right? This is called fourfold rotation. This phase, second, third and fourth. So you are getting four phases in a particular hemisphere. If you consider only upper hemisphere or lower hemisphere, you are finding four phases. So this is fourfold rotation. But while considering for fourfold rotation and inversion, that means fourfold roto-inversion, what we have seen, the axis is reduced to twofold. Okay, we have taken it fourfold, but it is reduced to twofold because in upper hemisphere we are getting two phases, in lower hemisphere we are getting two phases. Similarly in 2 bar also, if you see 2 bar, we will go back to 2 bar. If we will go to 2 bar, you can see in this is the hemisphere, this is the sphere, this is the upper hemisphere, this is the lower hemisphere. The axis is reduced to one fold. We have taken it twofold, but it is reduced to one fold. Twofold means what? You have to get same phase at 180 degree, repeated at 180 degree, but in 360 degree rotation you are getting only one phase. In the lower hemisphere also, in 360 degree rotation you are getting only one phase. So here twofold is reduced to one fold. Twofold is reduced to one fold. Similarly here fourfold is reduced to twofold. Fourfold is reduced to twofold. Due to this we are giving this symbol, roto-inversion symbol. If we use this symbol, in case of 2 bar we are using this symbol, in case of 4 bar you are using this symbol, right? That means in roto-inverser we are using this symbol. In 3 bar also we will use this symbol. In 1 bar that is I, that is it is not having any symbol. Okay, so if we use roto-inversion for each even one, twofold and fourfold, okay, then we will go to 6 bar. At 6 bar also the symmetry will be reduced. 2 bar is equal to m. I have shown you why. 2 bar is equal to m, because this is the first plane, rotation and then inversion. So they becomes mirror image of each other. They will look like mirror image of each other. So that's why that is a mirror plane. But twofold rotation means only one hemisphere, either upper or lower. So in the upper hemisphere there is only one phase in 360 degree rotation. In the lower hemisphere also at 360 degree, in 360 degree we are getting one phase. So twofold is reduced to twofold, rotation axis is reduced to one fold. Here fourfold is reduced to twofold. We have seen it here, fourfold is reduced to twofold. For every even symmetry like 2 bar, 4 bar and 6 bar also, in 6 bar also that will be reduced to threefold. We will see in the 6 bar. Next case is 6 bar. So we will see for every even symmetry 2 bar or 4 bar or 6 bar, that will be reduced to half. While considering for rotation, number of phases will be same. For 2 bar we are getting 2 phases. For 4 bar we are getting 4 phases. But if we talk about rotation, the rotational symmetry is reduced to twofold. 4 bar is reduced to twofold. Okay. So similarly 6 bar that will be reduced to threefold rotation. But number of phases will be 6. Okay. And if we talk about odd symmetry like 1 bar and 3 bar, odd number with roto-inversion symmetry 1 bar and 3 bar, you can see the number of phases is doubled. The number of phases is doubled. Okay, in case of 1 bar we are getting 2 phases. In case of 3 bar we are getting 6 phases. 1 bar is center of symmetry, 3 bar is your rhombohedral class or trigonal system, crystallizing in trigonal system, class of trigonal system in which calcite will crystallize. Okay, so that is the 3 bar. Okay, next moving to 6 bar. Next we will move to 6 bar. Let's see what is happening in 6 bar. So see, this is 6 bar. 6 bar means again 6-fold rotation plus inversion. 6-fold rotation plus inversion. So you can see the symbol here, that is a hexagon, and in between that there is a circle. That means that we are applying inversion to rotation axis. We are applying inversion to rotation axis. Okay. So see, this is the first phase, this is the first phase. 6-fold rotation means you will get same phase or symmetric phase or same motif at 60-degree rotation. At every 60 degree you are going to find the same phase. So you will find the same phase here, but we are not taking rotation only, we are taking inversion. So this is the temporary phase. We have to go to the lower hemisphere. To invert it, we have to go to the lower hemisphere because it is in upper hemisphere. So we have to go to lower hemisphere. We have to change the hemisphere. We have to invert it with respect to the center. Then that will be my final phase. Okay. So this is the first phase. This is the rotation phase, and then inverted back to the lower hemisphere. That is the second phase. Okay. Let's start it again. This is the first phase. This is rotation means in same hemisphere we are rotating, then inverted back to lower hemisphere. This is top front that goes to back bottom. Okay, this is the second phase. Then if you rotate it, that will go, this is the second phase, this is 60 degree, then inverted here. It will go to here, this is the rotation, then that will invert it to this side, then that will invert it to upper hemisphere here. Okay, then if I rotate 3, that will go here and invert it to here. If you see, this is the rotation phase. Mark here, mark this one, that is rotated, then inverted, right? It will be rotated here, then inverted back to here. If you can see the change here, this is the third phase. It will rotate to this one, it will rotate to this one, and that will invert to this one, inverted back here. Then fourth one will rotate to here, front, then inverted back to here. Fourth will rotate to here, then inverted back to here. That is the fifth phase. Okay. Then if you rotate fifth, that will go here and then inverted back to here. That is the rotation phase. This is the inversion phase. Then if you rotate 6, that will go here, and if you invert, that will come to 1 position. If you rotate it, it will go here and then inverted back to 1 position. I am going back. So see, this is the first phase. Just focus on the diagram so that you will understand. This is the first phase. If I rotate, that will come to top front, then I will invert, that will go to bottom back. Rotation, inversion. Then if I rotate it, that will go here and inverted back to this position. Rotation, inversion. Then if I rotate it, that will go to back side, then inverted back and form a phase below 1. So it will rotate here, invert, here. If I rotate 4, that will come to the front side, inverted back to back side upper. So if I rotate it, it will come here, inverted above 2, right? If I rotate 5, that will come here, inverted back to form a face below 3, rotated here, inverted to here, okay? Then if I rotate 6, that will go this side and inverted back to first position or the initial position. So the operation will stop here, operation will stop here. So what you are finding? You are finding 6 faces, 3 in the upper side, 3 in the upper hemisphere, 3 in the lower hemisphere. And if you see, the upper hemisphere faces are exactly top of the lower hemisphere face, like this. If you see from the top, you are finding 3 faces, because these are only the upper faces. The lower hemisphere faces are exactly below the upper ones. If you see, this is 1 and 4 are exactly below, 4 is exactly below 1, 6 is exactly below 3, 2 is exactly below 5. That means 4 is the mirror image of 1, 6 can be the mirror image of 3, 2 can be the mirror image of 5. That means I can pass a horizontal mirror plane here, so that the upper hemisphere planes, upper hemisphere faces are reflected back to the lower hemisphere, right? So we can see from the top that there are 3 faces, and there are also 3 below faces, because I have a plane of symmetry, which is horizontal, so that the upper hemisphere faces are reflected back to lower hemisphere. So this is the pattern, because it cannot be open form like this. The crystal cannot crystallize like open space, only there is a face and here it is open space. No, it should be closed. So if I will close that will look like this. In the upper side there are 3 faces, first, second, third. In the lower hemisphere, first, second, third. And this face and this face are what? Symmetric. Or they are like mirror images. If I will pass a mirror plane here, then upper part and lower part, they will be mirror image of each other. If you see from the top, that will appear like this: first face, second face and third face. Below first there is a mirror image, below second there is a mirror image, below third there is a mirror image. So in 6 bar we are getting 6 faces. But the 6-fold rotation axis is reduced to 3-fold. It is reduced to 3-fold, and there is another mirror along with a perpendicular mirror plane. If you see, this is the rotation axis, this is the rotation axis, right? This is the rotation axis, or this is the rotation axis, right? Where we are finding 3 faces, and mirror plane is perpendicular to the rotation axis. So 6 bar is reduced to 3 by m. So you can see here, 1 bar can be I, or that is center of symmetry. We are getting 2 faces. This is important, you should remember. 2 bar is similar to 1 mirror plane, because 1 is this face, rotated 180 and inverted, so both are mirror image like this. So that is the 2 bar, that is the mirror image. We can write 2 bar as a mirror plane. 3 bar means that is rhombohedral special form. It is having 6 faces, all are rhombus shape. 4 bar means that is 4 faces but reduced to 2-fold rotational symmetry. The 4-fold axis is reduced to 2-fold rotational symmetry, and that is a disphenoid. As I have told you, this is one sphenoid and this is one sphenoid. So it is 2 sphenoid. Okay, I have shown you the picture. Again I will discuss it while discussing different forms. What is the difference between sphenoid and dome and etc. These are very fundamental questions repeatedly asked in if you attend any interview, then they will ask. So I'll discuss that. So 6 bar is again number of faces are 6, but 6-fold rotation is reduced to 3-fold rotation along with one perpendicular mirror. As the mirror plane is perpendicular, we are writing 3 by m. We are writing 3 by m. Okay, this is reduced to 3 by m. So we have studied regarding these things. So what we have noticed here, every even symmetry with roto-inversion, every even rotation axis like 2, 4 and 6, they will be reduced to half of it, and every odd symmetry like 1 bar and 3 bar, that will be, the number of faces will be doubled. 1 bar will be 2, will give 2 number of faces, and 3 bar will give 6 number of faces. So these are what we have studied: 1-fold rotation, 2-fold rotation, 3-fold, 4-fold, 6-fold, inversion symmetry, 1 bar, 2 bar mirror plane symmetry, 3 bar rhomboidal, 4 bar 2-fold reduced disphenoid, 6 bar is 3 by m. Okay. Then combination of these again give some what new point groups. As in yesterday we have studied 2 mm, 4 mm like that. So combination of these also will give some new point groups. Okay. Okay, I am not going to this one. Okay, these are some of the pictures. So we'll see it later. Okay. So this is the table what I am going to show you. See, if we talk about rotation axis only, how many number of symmetry elements are how the classes are getting formed, how the different 32 classes are getting formed using the combination of these symmetries. I have told you basic fundamental is 1, 2, 3, 4, 6, then 1 bar, 2 bar, 3 bar, 4 bar, 6 bar, then the combination of these will give us different forms. Okay. So if we consider only rotation axis, that will be 1-fold, 2-fold, 3-fold, 4-fold, 6-fold. If we consider roto inversion axis, 1 bar that is center of symmetry, 2 bar that is mirror plane, 3 bar rhomboidal, 4 bar disphenoid, 6 bar that is 3 by m. Then if you combine two symmetry like 3 2-fold symmetry axis, 3 2-fold symmetry axis, that will come in orthorhombic system. I will discuss this. 2 to 2. Then again this is 3 2 that comes in cubic, 4 to 2, 6 to 2 like that. Then 2 by m, that means one rotation axis. This row, it is representing what? This row is representing only rotation axis. This row is representing only combination of rotation axis. You are not finding any mirror plane in this row, right? 2 to 2, 3 to 4 to 2, 6 to 2. So these are combination of what? Only rotation axis. I have not added any mirror plane. So the next row is one rotation axis and a perpendicular mirror. One rotation axis and a perpendicular mirror. If you see, this is 2 by m, 3 by m, 4 by m and 6 by m. So again 3 by m is equal to 6 bar. Okay. Then if you see, one rotation axis and then parallel mirror. One rotation axis and then parallel mirror, that is 2 mm, 3 m, 4 mm, 6 mm. And again I will here it is written parallel. Okay, that's okay. But I'll say something how m is. Most of the people think that if there is only m, that is parallel to some position like let's say I'll discuss it later, that will be good. But as just now I am saying people are getting confused that m means parallel mirror and something by m means perpendicular mirror. Okay, so people are getting confused like this, but I will say M means perpendicular mirror. In which position is it? It is in which position it is? It is perpendicular to that position. Like for example, I am considering this is actually I have not taught you yet, but still let's say here I will repeat it again. Let's say in orthorhombic system the positions are like ABC, or some people are taking also BAC, because sorry, it is either BAC or CAB. It is either BAC or CAB. These are the positions. Like if I'll say, let's say I am talking about BAC. What does it mean? If I write 2, 2, 2, I have told you this is the combination of rotation axis, two-fold rotation axis, two-fold rotation axis, and two-fold rotation axis. Orthorhombic, I have told you, orthorhombic means B is unequal to A unequal to C, and B is greater than C greater than A, like this. Okay, so B is greater than A and C. B is greater than this is not defined, C or A, but B is greater than C and A. I can write like this. Okay, C can be greater or smaller than A. So B is greater in orthorhombic system. So we are writing it at the first. Some people write like this BAC, and some people like this CAB, because most of the time people think that C is greater. C is the greater axis. C is greater axis in every other systems, but in orthorhombic B is greater one. B is greater one. Okay. So orthorhombic monoclinic B is greater. So you can see the first position is of B, and for this positioning also BAC, and I have told you yesterday some class 2 mm, right? People are also writing mm2. People are also writing mm2. Okay. So here two-fold is B. If you write BAC, then that is 2 mm. If you write CAB, then that is mm2. Okay. If you write BAC format in BAC format, then that will be 2 mm. If you write in CAB format, then that will be mm2. So both of them are correct. B is two-fold, M is perpendicular to A, M is perpendicular to C. Okay. Both of them are okay. Both of them are correct. Just the format is different. Don't get confused with this. I will repeat it again while teaching 32 class. I am just saying here, people are thinking, let's say here if I will say here BAC is the pattern, and I have written 2, 2, 2, that means B is twofold, A is twofold, C is twofold. Okay. If I write, I am taking that example 2 mm, BAC I am writing 2 mm, that means what? B is twofold, there is a mirror perpendicular to A, there is a mirror perpendicular to A, there is a mirror perpendicular to C. Okay. These mirror planes are parallel to B, but what I am telling, people are telling that if I write 2 mm, that means here also it is written one rotation axis and parallel mirror. One rotation axis and parallel mirror. As A and C are perpendicular to B, as A and C are perpendicular to B and they are mutually perpendicular to each other, you are finding, if you take M parallel or perpendicular, that will be same, because what is perpendicular to A, that is parallel to C. What is perpendicular to C, that is parallel to A. So there will be no confusion. But in trigonal system you are finding this confusion. Because they are not 90 degree. The axes are not 90 degree. They are at 120 degree. In trigonal system the axes are at 120 degree. In hexagonal system the axes are at 60 degree. 120 degree. In hexagonal system there are three horizontal axes. So they are at 120 degree angle to each other. So there people are also getting confused, and that's why they are taking some classes as there is separating some classes as like it is like this only. but that is not the case. M is always perpendicular. Wherever you place M, that is the perpendicular mirror to that position. Like here, if I have placed M here, means that is perpendicular mirror to A. That is a mirror plane perpendicular to A. So here, if I place M, M is perpendicular to C. M is perpendicular to C. Okay. If you write like this format, CAB, that will be M, M2. So M is perpendicular to C, M is perpendicular to A, and B is twofold axis. B is twofold axis, right? So, and what about 2 by M then? What about 2 by M? Let's say 2 by M, 2 by M, and 2 by M. 2 by M, 2 by M, 2 by M. This is also the normal class of what? Orthorhombic system. 2 by M, 2 by M, 2 by M. Again, I am writing in same format, B, A, C. What is the meaning of 2 by M, 2 by M, 2 by M? That means B axis is twofold and there is a perpendicular mirror. A axis is twofold and there is a perpendicular mirror. C axis is twofold and there is a perpendicular mirror. Because B is having both rotational symmetry, that is twofold, and a mirror plane perpendicular to it, so both rotation and reflection we are representing here in the position of B. That's why I am writing 2 by M. A is having a twofold axis, twofold rotation axis, and a perpendicular mirror. A is having a twofold rotation axis and axis of symmetry and a reflectional symmetry. So both the symmetry I have to represent at the position of A. That's why I am writing 2 by M. Okay. C is having twofold axis and a mirror plane also perpendicular to it. That's why I have written 2 by M. Okay. So it is having both rotation and reflection symmetry. Okay. That's why I am writing 2 by M, 2 by M, 2 by M. If it is not having any rotational axis, if it is not having any rotational symmetry, I am writing like this, M, M2. But M means what? M means there is a perpendicular mirror. This M is perpendicular to C. This M is perpendicular to A. B is twofold axis. Okay. Here also B is twofold axis and having a perpendicular mirror. Okay. So if you are not getting, then I will repeat it again in 32 class. But still, one more example. Let's say I am talking only about B axis. It is in monoclinic system. It is in monoclinic system. We are talking about B. If I write 2, that means B axis is twofold. If I write M, I have told you monoclinic is only having one position, that is B. Okay. So if I write 2, that means B axis is twofold. If I write M, that means that is the M perpendicular to B, mirror plane perpendicular to B. Perpendicular to B means that is AC, that is AC plane. It is not parallel to B. The mirror plane in monoclinic system is not parallel to B. Okay, that is perpendicular to B, that is AC plane. If I write 2 by M, that means B is having twofold axis, B is having twofold rotation axis, and there is a mirror plane perpendicular to it. And there is a mirror plane perpendicular to it. That means in B position we are representing both twofold axis symmetry and a reflection symmetry perpendicular to it. That's why we are representing it 2 by M. If there is only axis, we will represent as 2. If there is only mirror perpendicular to it, we will represent as M. Okay, if it is having both, then we are going for 2 by M or 3 by M or 4 by M or anything. But M means what? It is always perpendicular. Okay, most of the people getting confused, or they are also saying, many books are also written that M, if that is only M, then that is parallel. If that is by M, then that is perpendicular. That concept is wrong. That concept is wrong. M means there is a mirror plane perpendicular to the position or the axis. I will prove it. Okay, I will prove it while doing all the 32 classes, you will get same pattern. You will get same pattern what I am saying. Okay. So, okay, coming back to the